morning and welcome to the Reuse Company webinars. You will be muted during the webinar, but if you have any questions or comments, you can use the questions section. The webinar will be recorded, and in a few days, we will send you the link to the recording. Today's topic is data dictionaries, the springboard towards high-quality system requirements. My name is Cecilia Karlsson, and I will be hosting today's webinar. With me, I have Elias Josfi, who will be presenting the topic. This is the agenda for today. First, we will have a short introduction to the Reuse Company, and then we will see what data dictionaries are and why we should use them. Next, we will see how data dictionaries affect the quality of the requirements. Then we will learn how to tailor a data dictionary. After that, we will see a demonstration, and finally, we will have some time for questions. Okay, so let's start with a few words about the Reuse Company. The Reuse Company is a tool vendor specialized in the application of reuse methods, semantic technologies, and artificial intelligence to improve the digitalization of the systems engineering processes. Here is an overview of our tools. We are usually known in the market for our software tools for requirements engineering. We have RQA Quality Studio, RAT Authoring Tool, KM Knowledge Manager, Traceability Studio, V&V Studio, REX Requirements Engineering Tool for MS Word, and our newest product, Sales Engineering Studio, which offers connectivity and interoperability between systems engineering tools and technical management processes. Today's presenter, Elias Josfi, is a senior key account manager. He has a master's degree from the University of Montreal and the IMT Atlantic School of Engineering. He has a technical background in energy and mechanical engineering and has also been involved in research projects. Elias is passionate about international projects and languages. So over to the presentation. Good morning, Elias.
Good morning, and thank you, Cecilia, for the introduction. So welcome everyone to this webinar about the data dictionaries. And so let's jump right into the topic. The first section will be about defining what a project dictionary, data dictionary is. And let's start with a very broad definition of a data dictionary to understand the context and what we need to make sure we have an appropriate data dictionary for requirements engineering. So one of the definitions of the data dictionary is the fact that we centralize information about data, which could be of various forms. It could be the meaning. So we talk about the wording and why it is important to have a good wording in the requirements. Relationships that can be defined between the data, the origin of the data, the usage, and very important as well, the format. So it's not just about a list of contents that you have in a repository. It's also about how this content is being written. So there's a link to the syntax as well. So we usually have an organization level data dictionary. So within the company or an entity or a project group, we would have a common ground on the terms that we're using to make sure we don't misuse some of them. And the translation within a project that is developed in an organization is what we call the project data dictionary. So that means we have the organization level data dictionary that should be tailored, adapted to the project. That could happen if you have some variation in the definition of an acronym or a word in general, and you would have to specify a little bit more the generic definition. So the data dictionaries can be organized in different levels. So if we talk in the field of needs and requirements definition, we can define the data dictionary as a set of standards and guidelines to enforce the use of common vocabulary and concepts. So the idea is to ensure we talk the same language, we are consistent across the project team, and we don't introduce any ambiguity. So we'll see later that this is a main cause of defects in the requirements engineering definition. So in terms of level of maturity in the data, of course, data is the first level. So if you look at the figure here, this is basically just a piece of material that doesn't have any contextualization, is not organized, and the more you climb up this pyramid, the more structure you have. So it's not only about collecting data, it's also creating value with this data, and that's what systems engineering does by creating the concept of knowledge, which is a structured asset that you will be sharing across the organization, which also appears as one of the organizational project enabling processes within the set of processes involved in the life cycle of the system. So that means this knowledge management process is providing inputs to all the other processes. So you need a proper knowledge management process in the system development lifecycle to make sure you run all the activities successfully. And so if we exaggerate a little bit the context of the need for project data dictionaries, we could use these two examples. So they're very simple. The idea is to try to translate this into a complex system context. So if you have ambiguity in very simple examples because you don't define properly the format or the wording, then you can imagine what would happen in a big project. So this is an example of a format. We know that we're talking about a date, that's for sure, but what format are we using here? Usually, most of the European and Western countries in general would consider this as August 12th, 2023, but in some countries we reverse month and date, so we would be talking about 8th of December. So which one is the correct one? If you don't have a proper definition of the format, people would do the mistake of thinking it's one or the other. So you cannot let this huge ambiguity in the deadline of a project or the availability of a component for a project. So you need to have a clear understanding of this. And if you take it to the next level and remove 2 of the digits here of the year, you might even think it's totally reversed, and this would be let's say if you're not talking about the 12, so if you're talking about the 24 here, you don't know if it's 2024 or 2023, for example. So yeah, we would go to another example here, acronyms. So depending on the language, acronyms describing the same concept can be different, and you have to make sure that everyone understands the acronym the same way. So it's about the formatting, it's about defining the standard language of a project to make sure we don't have this misunderstanding. And we'll see later that it is a challenge to anticipate how stakeholders would understand the different concepts, because even though you start defining the common ground, if you don't take into account the cultural and language aspect, you might end up with the ambiguity in the project. So other benefits of using project data dictionaries are the following. So consistent wording formatting, as discussed earlier. So pre-established by the experts in the project, that they know what the best wording and formatting will be for the project to reduce potential ambiguity. And it's also a good fuel and support for standardized requirements structures modeled in patterns, so what we call smart authoring. Enhanced traceability, so either manually tracing the objects or just using NLP algorithms to do so. The fact that the structure is standardized and that the wording is the same can easily help match different objects. So I'm talking about the same concept. I'm providing the same service to a user, so that would be easily traceable, even from algorithms if you have a proper standard language and structure. So avoid inconsistent statements. So of course, if you use a consistent wording and formatting, you avoid misuse of a concept in a requirement or any statement in general. It helps also assessing the completeness of a specification with regards to the model architecture. So let's consider we would like to make sure all the functions of a system are described. If these functions are also represented in the model, the fact that we use the same language than the one in the model, the same verb, the same object, then we would easily assess the completeness. If I'm describing the function with a different wording, then we don't have, if you're doing completeness assessments with NLP-based assessment methods like metric checking the quality, then if you use a different wording, you might not find the match. So that's also a good way to help assessing the completeness. And also in general, taking a little bit of height here, improving the semantic analysis to find redundant or inconsistent statements within the same document or piece of project. In general, this would consist in checking duplicates, for example, or contradictory statements. So we talked about models just before, and we usually make those two concepts compete, so natural language and models. And we do need natural language to be involved in, especially in requirements definition, because this is what contains the human dimension, all the cultural, social aspects that we must take into account when developing a system. So I'm developing a system that I will be introducing into a market. So depending on the market I'm introducing the system into, I will have some different aspects that I have to take into account, and those cultural, social aspects are usually not taken into account in models because we do want the modeling language to be universal. So we usually lack the human dimension in modeling languages. So it's good for the interpretation that you reduce the room for different interpretations in models, but you also lose some unsaid information, implicit information. So we do need textual requirements written in natural language because they are what enable the translation from the human needs to design input requirements. So the best language for requirements is natural language. That was theorized by Abbott and Moorhead even before we started talking about systems engineering, and I believe this statement is still true when it comes to defining requirements. So let's jump into the link and the importance of data dictionaries with regards to requirements quality. If we look at this, these figures here coming from a project to check the most common requirements defects, we see that Some of them highly ranked here are linked to the need for project data dictionaries. So ambiguity, so that goes without saying that if we don't define the wording, then we will end up understanding different things the same way, or using one word for another. This leads also to inconsistency because you don't have the requirement at the right level, or you do think that two requirements mean the same when they're not, because they're actually two different functions described. It's not precise enough because usually when you start writing, you don't go in at the maximum level of precision. You need some help to do that, and this ends up making requirements not understandable. And we could use some of the others to consider that the project data dictionaries are important. For example, if we rely on NLP algorithms to do traceability, the fact that some of the requirements are not properly expressed make that some requirements will not be traced, or at least traceability will be harder to reach. So higher chance that some requirements wouldn't be traced. So we have some consequences here. Semantic contradictions could also be involved. So using of synonyms with multiple meanings. So you see that everything could be directly or indirectly linked to the lack for proper data dictionaries. So ambiguity would be, for example, the use of misused acronyms. The inconsistency would be the wrong definition level. So I'm not on the right level for the function breakdown structure or system breakdown structure. I'm writing similar requirements without actually seeing that from the human perspective, because I'm not sure that I'm using a synonym or not. So I need a data dictionary to help me detect these kind of issues. And the undefined terminology make the requirement not understandable or not precise enough. So we have well-known quality characteristics for requirements. So the SMART characteristics checklist is one of the example. It's usually a translation of what we have in different standards like ISO 29148, and we see that some of the characteristics will involve data dictionaries like correctness. So using a good wording, using the appropriate level, what we said before. And ambiguous, that comes also with this. Consistency, using one word and for only one situation, not mixing the meanings of different concepts. And as I said, other consequences that could come from not having those characteristics. For example, lack of precision could lead to requirements being unverifiable or untraceable, for example. And so data dictionaries help comply with those characteristics and make sure we have them all complied with in your projects. So the INCOSE guide to writing requirements is also one well-known reference for rules to write well-formed requirements. So if you would like to check more about this INCOSE guide to writing requirements and the newest concepts that were developed for the version 4, I invite you to join this link to check the recording and the slides. So an example of this INCOSE guide to writing requirements is the rule number 3, which talks about the appropriate subject verb backbone of the requirement. So we need a proper subject verb backbone in the sentence to make sure that the rest of the sentence will be providing information that we can relate to something in the project. So we have to get the subject properly defined. So what is it? A system? Is it a component? Is it a function? A user? Same for the verbs. Is it any action verb that I'm allowed to use in the project? Is it a system composition verb? Is it a state transition verb? So this helps not only understanding what we say, but also if we use the some NLP based algorithms, we can define, for example, for the system composition, if I have one system and one component involved, then I will be able to generate relationships in a model between this system and this component. So we can use interoperability algorithms to generate models from model relationships from the text using a proper structure. So that's also important for that. And Appendix C of the INCOSE Guide to Writing Requirements also presents a set of patterns for appropriate structures. And we'll see an example here. A functional requirement could be structured with those slots here. Each slot has different options that you can choose, and I'll use an example just after. And some of the slots are optional, but the common characteristics of all these slots is that the elements that they involve are can be input in a project data dictionary. So what is an agent, what is an entity, what is a stakeholder? So we should make the difference between all three here to make sure we talk in the appropriate level and we don't talk about something that is not defined. So in this example, we see the structure. So if we follow the pattern, we write, for example, the condition word while then we have a condition, the system is available. So it's condition is usually a Boolean situation, like yes, no, is it available or not? Is the temperature higher than or lower than? So it's a check that must be easy to understand. The agent here is the user in this example, the shall verb that we can enforce the action, enter the information data, qualifying clause. This could be an optional clause in some requirements. So as defined in the user manual and the constraint within 5 minutes. So if we focus on the condition slot, then you see that we have different ways to structure the requirement condition. So different structures are enabled by this Appendix C pattern. We have some examples here. Control system is in ready mode. So this would be the agent would be the control system. The state would be the ready mode. Here, control system is initialized. Temperature of the sensor reaches a value being 90 and the unit. So all these concepts of patterns are implemented in a data dictionary that then provides this to the user so that we make sure we follow the structure appropriately. So in the INCOSE Guide to Writing Requirements, if we come back to the verification of the requirements, we have different characteristics and rules. And those rules, when we would like to tailor the rules, so the rules are usually qualitatively described. So I want to have on atomic requirements, non-ambiguous, avoid vague structures. So, but what does that actually mean? So we need to measure those characteristics, and that's how we translate the rules into metrics. So we need to measure, and the measurement is only possible if we have data. So same as if you do a survey, then you have an input of data that you will use to conclude on your survey. So that's the same approach. We need data to measure, and this data would be also coming from the project data dictionary. So what will we be measuring? So terminology and acronyms. We're using the main terms or a synonym? Are we using an acronym but with the wrong meaning? What level are we describing in the taxonomy of the system, etc. So we need to describe what we are measuring. So an example of the requirements verification for and the use of project data dictionaries. In the new version of the INCOSE Guide to Writing Requirements, we have Appendix D, which is the rule applicability matrix. I'll also explain later what dimensions we have in this matrix. Each rule is assigned an applicability level and if the scope requires a project data dictionary or not. So here in this example, all the rules require a project data dictionary. So subject verb requires to define what is a subject and what verbs we allow. Defined terms, that's the glossary. So we need the input in the glossary and the definition. Is the spelling correct? So is the word coming from the language, or is it a new word that we need to declare in the vocabulary? And in the same for the acronyms. So in this example, I have a word which for a standard database wouldn't be like a defined entity. So we need to define that. So this would call all the metrics, and all the metrics would flag this as an error unless we have this input in the vocabulary. And I'll show during the use cases at the end of the presentation how we could suggest this word to be added in the project data dictionary. So some collaborative mechanisms to feed the project data dictionary. So it's an invalid subject. The term is not defined. It's detected as a misspelled word because apparently this is not in the language, and it's an acronym that is not defined. So here in this example, if we write that with all capital letters, the only rule that doesn't appear here, it's the misspelled word, because the spell checker, when it's all capital letters, usually doesn't flag that as a misspelled word, which is what you would see with the red underlining in Word or in any other document writing tool, for example. And so that's why we have all these three rules appearing. So the subject is not defined, this is not a defined term, and the acronym is unknown. So in project data dictionaries, the word dictionary is probably the one that we know of also outside the context of system engineering. So like a dictionary, when you're not sure about the meaning of a word, you can request the tool to show you the definition. So here, what is a management system actually? So I have to check. This is a system element, and the definition is a system entity responsible for processing, storing, communicating the information gathered throughout the operation of the system. So with this context, you understand clearly what you're involving in your requirements. So coming back to the rule applicability matrix that I mentioned, the idea is to provide different set of and subsets of rules to apply the rules from the INCOSE guide to writing requirements at the appropriate level, considering also the information you have in your project data dictionary. So the two levels, A and B, are for requirements and needs. So need statements and requirement statements are not assessed using the same set of rules, because needs can have like a looser syntax, and maybe as you're more high level, you're not getting the same precision in what you're writing. So some rules will not be assessed. Maybe you're not expecting any value with tolerance in the needs, because you don't even know the actual value when you define your needs. But when it comes to requirements that translate these needs into design input for the system development, then you need to get deeper in the accuracy and define the actual value and tolerance. So that's why we have these two levels, and the level 1 and 2 is considering cross-domain versus domain-specific data. So some rules, most of them in the INCOSE guide to writing requirements, can work without having a specific project dictionary. Of course, we need a dictionary to know that we are using the passive voice, we're using the negative expression, because we have to tell what is a negative expression. So also in this case, we also need that to be stored in a data dictionary, but this is common to all the organization and even across an industry or just because it's a language fact. Like a negative expression, the word that is considered a negative expression will not change from one organization to the other. as soon as we keep the same language. Whereas domain-specific aspects like defining a proper subject or a proper acronym, this would require a project data dictionary, and that's why we have these two dimensions defined here. So we verify the needs on level A and the requirements on level B, and depending on the application of data dictionaries, 1B or 2B, 1A or 3A. So the details about this are described in the webinar that I referred to earlier. So now that we know what is at stake when we define a project data dictionary and what elements we need to start with, let's talk about how we tailor the data dictionary. So of course, if we talk about requirements verification, it's important to have in mind what is the expectation. So what level you'd like to reach in terms of checking the requirements, but also how these requirements are actually written right now. Because one of the challenges is that we have to make stakeholders understand each other, and when you input this kind of processes in an organization, you have to start from a basis. We cannot change completely the way people write requirements. People will adapt to the new standards and new practices that you will be setting up in an organization, and we have to start also understanding how they think to adapt the rules we are implementing. So the idea is to shorten the distance between what the stakeholders think and how they think, and also how the machine would think, so that we would assess properly their statements. And we have to deal with that because we would like to avoid unwanted situations when the message is distorted, generalized, or when we actually delete, when we lose some information. So if we don't understand properly the stakeholders, we might skip some information which would not be reflected in requirements, and that would end up in incomplete specifications, and then this could harm the overall development of the project. So this is what we would like to avoid, and the challenge is here. So we have a language versus culture aspect. So in most projects, we use English as the language for drafting requirements. So one thing is using the language, and the other one is the culture. So we all use English in international projects, or mostly, but we come from different cultures, so we don't understand English with the same level of knowledge. We don't translate the same way the English to our native language, and also between two persons from the same culture, identity also comes into account. So basically, what we say is here, every person has a different sensitivity when it comes to understanding, and this is the main challenge. And we would like to reduce this distance between what people would think like and what we would like to have the machine process. And the more standardized, the more ambiguity-free the vocabulary is, the less chance we have to end up with distortion of information or deletion, and caused by this language, identity, culture cycle. So we would like to convert the human communication into something that the machine can understand, to get help from algorithms and gain in efficiency in our projects. So when it comes to requirements verification, the rules that we use to check the requirements quality, most of them rely on data dictionaries. So the more rules we would like to involve, the more the thorough the assessment will be, the more concepts we need to be defined in the project dictionary. So I will show you how we usually work to structure the project data dictionary. But this is important to know. The higher the expectation is for the requirements assessment, the higher the content is needed in the data dictionary to make sure we assess the rules properly. So the more domain specific we go, the more data dictionary we will need. So that's more or less what is at stake, what is the challenge. But now let's talk about how we can tailor the structure of the ontology and what do we need for that. So it's usually what we foster as an approach is thinking about the ontology, which is one of the forms that project dictionary can have. This is how we would like to structure the data dictionary for different reasons that I will explain in the next slides. But we have to think about this as a building with different floors. So you don't start building the third floor without having the first. So to be able to define structures, which is usually the maximum level we have, because we need proper structures to detect information, to extract information from existing legacy documentation. So before we do that, we have to define the wording, so vocabulary. And in the vocabulary, usually we work in a modular way. So projects involve common vocabulary, which is generic to the organization, and specific vocabulary. So you all start from a centralized ontology, which is one native content in the database, and then you can plug external knowledge either imported within the native ontology, so that makes a bigger database that you grow as the project goes by. You can also input new levels, so the knowledge library, which contains specific standard information or wording. So this is maintained in another support, and it can be input in the working database as the project goes. So this is a partition of the main content. So this could grow separately and be plugged into the main ontology. And then you can also, so that's why we'd like to work with ontologies. It's also the fact that we can structure the knowledge between different sources. So we can have sources of truth coming from another document, which can be plugged to the ontology, a model, and even other databases. So the idea is that some knowledge will be input into the database and it will be available right away, while other knowledge will be connected from the tool using connectors and APIs to get external data, and this will be updated externally, and we could get the information read in real time without having to actually manage it within the database. So the more information we get from outside, the bigger the ontology, and also the more precise. So if we talk about vocabulary, we usually define the terms, their synonyms. So what is the main term? What is the second option? And also we classify the terms within different groups, what we call clusters in the tool. So for example, this is a system. I call it RQA, which actually means RQA Quality Studio. We can have the synonym for that, history node, version, and source, for example. So the synonym is defined here. You see, it's RQA Quality Studio. So that in the end means if I use this instead of that, the tool will understand the same. So, but it can also tell me don't use that because it's too long or because this is not the main term. Use that one, and the tool can suggest you to change that and provide you with the suggestion. So second level is the architectures. So you have a vocabulary defined, you more or less have an idea of the different concepts. You start defining the architectures. So you have functional breakdown structures, property allocations defined, and this is connected from a model, for example, and you can see the structure and merge different models together to see the overall structure. So some of the architectures could be defined in model 1, some others in model 2, and the overall structure would be built, merged within the tool. And level 3, patterns. So we have pattern libraries that you can import into the database, and this is what enforces the structure of your requirements. What is a functional requirement? What is a non-functional requirement? How do I describe the condition? We have different available libraries that you can download and just import within the native ontology you're working with. So some examples here: years, sophist, and the appendix C that I described earlier in the presentation. And here the signals, so we can go to some complex aspects. So this is a pattern. You have a syntax, and then you have to follow the syntax to make sure the receiver can receive the signal I'm describing. The sender can communicate with this receiver. What is the unit? So you can use the intelligence of the tool to make sure you have a valid signal. And this helps growing getting a better experience in traceability, in semantic search, finding overlapping signals, for example, helping in having the proper completeness, etc. So all those characteristics that we need for a successful project development. So as I said, apart from the content, we can also organize the relationships between different repositories. So that's why the data dictionary can have different forms. It can be an ontology, but at the same time connecting to files and models. So the data dictionary is the overall context, and the ontology is one of the ways to organize the data dictionary. So here we have information spread across different sources, and each source will provide information that will end up matching the pattern. And right now with the tool, we can work in different languages, up to 8. Some languages are being under development right now. And so if one of your languages is right here, then that means you could start building your own project data dictionary to work with the tools. So let's go to the data dictionary involvement in requirements verification. So if we go to the first of the examples here, we just rely on the tool to check that we have the proper vocabulary used in the requirement, or in that case, it would be a requirement statement. So you write the requirement, and then you end up asking the tool, okay, so how is it actually, so you have a passive voice here, shall be notified. So this is the rule checking. So that's the idea. So we have to use the appropriate set of rules for needs or requirements. That's important. But here in that case, I'm writing requirements, so no passive voice, no vague term. And here I can also ask the tool, what does management system actually mean? So that's the screenshot I showed you earlier in the presentation. So you can view the information and see that this is my definition. And you see the synonym is control unit. So and so the other example would be, okay, so if I have something that I don't know, which is not in the vocabulary, I would get the typical spell check error. So it's misspelling. So the 4 rules I mentioned are here, because now it's with a small a. So we need to suggest that to be input in the ontology. So let's go. We can select the misspelled word, unknown acronym, unclassified term, and add it to the domain. So we send a suggestion to the domain. So we write the description to help the dictionary manager, the knowledge manager, understand what we need, and then the knowledge manager can actually see the suggestion and decide to approve or reject the suggestion, sending a message to the person that originated the suggestion. And then if we want to accept the suggestion, then we classify the term as being announced. You see the icon gets checked here, and the term gets imported. So it gets created and stays in the database as a new entry. So you see here that this is the new term created. So second example of the use of data dictionaries, in this case for completeness checks. So in this case, we have a model feeding the data dictionary with an architecture. It's a package diagram, and we connect the model in the knowledge manager in the ontology. So the model is plugged to the ontology so that we can use the ontology content to write a proper requirement, and this requirement will help assess the completeness of the function allocation. So am I describing all the functions? Am I allocating the function to the right function to the right system? So there are a mix here of completeness and consistency checks. So this gives you the spectrum of what we can do with this kind of data. So in this case, if we define, for example, we want to find the completeness. The completeness is one of the 3 dimensions of the quality in the tool, together with correctness and consistency. And the completeness here will be assessed by checking how many of those functions that come from the model will be involved in the specification. And here you see that these functions are identified from the model. So every time the model, the completeness is assessed, we will recalculate the terms. So this means checking that the model has changed or not, and taking the new entries or deleting the entries that were removed from the model. So we keep the consistency at any time between the specification and the model. So we do that to define the coverage we'd like to reach, and basically the tool will count. We've tried to find in the specification how many of those functions are found. So that's the evolution enabled, so we can check at evaluation time that the content of the model changed or not. So it's not static, it's dynamic. That's one of the advantages of the knowledge interface with the model. And there's another metric to check the relationship between the system and the function, so the function allocation. And the same here, we enable the evolution to be checked. So is the model the same? And we check every time we run the assessment. So if we run the assessment here on the completeness side, then we can check that, for example, here we have a 17% result. So the results for completeness are a percentage of the completeness rate. So in the other one is 29%. So we have 29% of incompleteness. That's the way it goes. So 0 means it's complete, you don't have any missing term, and the more you increase, the more incompleteness you have. So that's what we measure, actually, the incompleteness of the specification. So based on this reference, we check how many of those are not found. The red zone is what is defined in the metric but not found in the specification. The green is what we defined in the metric as the reference and what we actually wanted to check. And the specification one is, I have some functions in the specification that I didn't define in the metric, so it's a potential case for over specification, for example. So these are some examples of completeness checks using data dictionaries powered by models. And the last example is, how can we use patterns and data dictionaries to enforce a consistent writing? So in this example, I'm using a web extension of the RAT authoring tool in CodeBeamer, in the CodeBeamer ALM. So I will be editing, creating a new requirement in the specification, and I'll be using the data dictionary and the patterns to make sure I have a proper requirement. So my cooling system functionality will be described using the pattern. So the pattern library is available in the tool, so you can select the pattern group you'd like to you'd like to use. So pattern groups would be different kinds of requirements. And after you start typing, the quality assessment and the pattern assistance are turned on. So that means you can see in real time that the metrics are being checked and that you're matching the requirement pattern so far. So you see the structure, the different structures that can be used in this pattern. So we have optional slots and we have different conditions that we can write. So as you saw in the slide with the appendix C pattern. And here we follow the pattern. So we have a free condition text. In this case, it's a complex condition with while if condition. So both state and event driven condition. And then we start writing the requirements. I just skip a little bit. And you see that once I do the article, I'm expecting a system name. So those are coming from the data dictionary, the knowledge ontology, which can be connected to Excel, to models, etc. And we see that when we write the cooling system shall decrease temperature. So here it might seem that I only have one defined function in the model, but that's not the case here. We actually have a context restriction that relates the function that I would be suggesting to the corresponding system. So if I change here the cooling system by heating system, I will get another suggestion, not this one. And so that means that we don't suggest all the data dictionary we have. It's not about flooding the user with information. It's also suggesting what really matters to the user. So in this case, if we write heating system, now we're not expecting decreased temperature, we're expecting increased temperature. So it's suggesting just what you need. So if the function is not performed by this system, or it's not the right level, it's not going to be suggested. And so then we can finish the requirement, and we can use the save button on the top to keep the requirement and keep working. And then you just use the interface in the tool. So that's all for the presentation. I don't know if we have any questions, Cecilia.
Yes, we have a couple of questions already. But I will give you a minute if you want to comment anything or ask Elias something. Please write down your questions in the questions section. And meanwhile, I will tell you about our next webinar. How to avoid duplicated or overlapped requirements to get a more profitable project. Writing requirements takes a lot of time and effort. So is there a way to avoid duplicating information and save time and money? In this webinar, we will see a RAT authoring tool, which can be connected to most of the common requirements management tools. For example, IBM DOORS, PTC CodeBeamer, Siemens Polarion, and PDF, MS Word, and Excel. And this offers detection of duplicates in real time. We will also see the SES Engineering Studio, which is a more sophisticated tool that allows finding duplicates within a document or comparing two different documents to highlight a list of those couples with the most semantic proximity. So the dates for this webinar are the 12th and 14th of December. So over to the questions. As suggested, the tool detects new or updated words in an external glossary. For example, model-based systems engineering modeling tool. Does it notify the requirements engineer that new requirements may need to be captured, or does it need to work with the tool to verify completeness?
So yeah, thank you for the question. Here, if I try to rephrase that, so if the need is to make sure we have completeness, you need to rely on the assessment of the tool. So the tool is connecting through the knowledge ontology, connecting to the source, which would do the model in that case. And each time you assess the requirements, specification, or any other kind of objects, you get the result with the model version as it is at the moment of the assessment. So if you'd like to get updates, regular updates, you would use one mechanism that the tool enables, which is the batch process. So you would have regular assessments scheduled, and the users would get the feedback like daily or weekly feedback from the tool to see the evolution of the completeness. So that would be the way you would make sure that you reach the completeness. So some days you would increase the completeness because you're specifying the requirements, the document, but if the model grows, then you would also drop in the completeness. So that way you see if you're catching up or not. So I hope that answers the question.
Okay. Is the tool using any AI methods, for example, data mining, to identify new words from a glossary?
Right now, what we use is mostly NLP. So it's first level, I would say, first level AI concepts. But we are working on having more algorithms to help in the discovery of vocabulary in legacy documentation. So right now, what we do is we run assessments that find these unknown terms with patterns, as mentioned, so we know what kind of vocabulary we're expecting from the legacy documentation, and then we input this into the tool using the import widgets that I mentioned earlier. But we are working on algorithms to help in the discovery, actually suggesting the user to get this information, and all those tasks could also be scheduled, and also that way the ontology would be learning from the documents that you connect, and it would be more like a AI-based algorithm in the future. So right now this is a capability that is being developed by our teams.
Okay, thank you. Next question. Thank you for the presentation. I work in the railway industry and we have many projects in parallel with plenty of common data. Is there any way to work with several projects or dictionaries, as you call them?
Yeah. So in that case, when you connect to the document you'd like to assess, so in SAS Engineering Studio, which is the platform in which you have the quality assessment and some of the other capabilities like the traceability, the first step is to connect to a project database. So each project database has its own vocabulary and concept. So if you'd like to work in parallel, then depending on the project, you connect to your database, and when it comes to tailoring these data dictionary, if you work in parallel, you can create. There's a mechanism called knowledge, so ontology federation in the tool. So that means you create a link between all the ontologies, and that means you can edit several ontologies at the same time. So you can say, okay, I'm federating all the ontologies of my teams, and I would like to add the new glossary, update the glossary to all these knowledge repositories. And by doing this one time, I'm doing it for all the federated ontologies. So you create some kind of population of ontologies that will be growing at the same time. So that would be one of the mechanisms to efficiently organize your knowledge across several projects. So I hope that was the meaning of your question. Otherwise, you can just write an email and we can discuss that further.
Yeah, thank you. Okay, let's take a last question. Hi, can I connect a glossary stored as an IBM Doors module that is a module only containing the items of the glossary? Similarly, what if the glossary comes in a PDF file?
Okay, that's a good question, because usually we have existing glossaries in other tools. So if you'd like to switch to the System Engineering Suite to manage your glossaries, then the right thing would be to start with existing glossaries. And in that case, we have several connectors. We have about 50 connectors in the tool. So the mechanism would be to connect to our to your legacy repositories and just drop the information into the ontology using the connector. So you get the connector, using the connector, you get to the information through SAS Engineering Studio, and you can then copy this into the knowledge ontology so that it can be reused in other projects. And then the ontology becomes the source of knowledge. It's no longer the doors or the PDF content. And if you want to rely on these content as an external source, you have the knowledge interface mechanism that I mentioned earlier. So it's up to you to decide if you'd like to have this content imported as a native content in the ontology, or if you'd like to keep that external so that people can still work on their own files. And then you just pull the information from those files to assess your quality, for example.
Okay, thank you. So let's finish here. Thank you very much, Elias, and thank you everybody for attending. If you have additional questions or want more information about the tools, don't hesitate to contact us by email directly to Elias or to contact@reuscompany.com. You can also find the previous webinars on our web or our YouTube channel. Thank you very much and goodbye.
Thank you. Bye, everyone.